So this is a practice video on quadratic sequences, and let's start straight away. So here we've got a pattern of squares, purple squares, and they're going to grow like this, and then like this, and finally like this. So this is the sequence that we're going to work from. This is our first animation of 3, and a good idea will be to pause the video when you think you've got the problem and try and do it yourself, and then work through, compare how you did it to the worked solution. Okay, so what have we got here? Let's go back. So we start with 4 squares, so let's write that down. So here's the sequence of 4. Let's write it here to give ourselves plenty of room. And the next one. Well, I can see, actually it's quite interesting that what's happened between there and there is this one here seems to have squared. This one here we might think of as squaring as well, and maybe this one as well. Okay, but obviously not just squaring going on because we've got these 2 on the end. So it's interesting to look at these patterns and see if you can visually see what's going on. But really the way we solve these is by working through the numbers. Okay, so how many have we got in the second term? Well, we've got 1, 2, 3 times 2, so we've got 6 here, and we've got 4 here, 4 here, so we've got 14. Okay, second term then is 14. So it's just a question of counting these things in the first instance. Okay, so that's our second term. What do we have next? Okay. Right, again, these seem to have squared. So we've got 9, I won't write it down this time, 9, 9, and 9, that's 27, plus this 3 here, so we've got 30. Okay, 30. And for our fourth term, what have we got? Well, we've got 3 squares here, so that's 3 squares of 4 on each side, so that's 16, add 16, 32, 48, 3 16s, 48, plus 4 gives us 52. So 52. And that completes the sequence. And what they want us to do is to find what the term-to-term rule is that produces this sequence, and I guess that would produce a lot more growth. It would keep going. Whoops. So we write... there we go, we write not 0, we write dot dot dot. Okay, dot dot dot. Keeps going. Okay, now the very first thing we do when we've got something like this is find out a little bit of extra information. And what I've got here is the first term, second term, third term, fourth term. What about the 0 term? So we work back a little bit, and then we're going to be able to get our term-to-term rule. So first of all, I'm going to get my first differences. Well, the difference between 14 and 4 is 10. The difference between 30 and 14 is 16. The difference between 52 and 30 is 22. So I can see that my second difference is going to be 6. Okay. And so if I subtract 6 from 10, I'm going to get 4 as this value here between the 4 and 0 as my 0 term. Okay, because 4 subtract 4 is going to give me 0. So that's good, that's got my 0 term sorted out. Now my second difference, well, my second difference is going to be the same in a quadratic sequence. So 10 subtract 4, 6. Just worth checking the others. 16 subtract 10, 6. And 22 subtract 16, 6. Okay, so that's constant. And what it means is that I can now work out my my A, B, and C values. Now, if you're not sure, if you've just come across this, I'll just remind you, let's write it up here, that the standard form for a quadratic is going to be a n squared plus b n plus c. Okay, so that's the standard form for a quadratic, and usually instead of writing y equals, we put u or t equals. So u sub n is probably the most popular convention. So there's my standard form. Let's now get our values for a and b. Let's go back to a, b and c rather. So of course with the first term n squared is going to be 1 and so on, and with the 0th term n squared is going to be 0 and it's only c. So the first thing we can get is that c value, okay, which gives us the last part of our term to term rule. So what's c going to be? Well, c is just this term here. C is going to equal 0. Okay, so I write c equals 0. So that's sorted that one out. Now I can get a plus b, because a plus b is going to be my first difference between 0 and 4, the 0 term and the first term. So it's going to be this one here. Okay, so a plus b, and check out the tutorial on this if you're not sure how this works. But a plus b is going to give me 4. Okay, and finally I need to look at these 6's here. Okay, so all of these, well, we'll just circle 1. But these are constants, so perhaps if I do a little arrow, just say including all of these. So they're all 6, and we know that twice a, 2 times a, gives us our 6. Therefore a must equal 6 divided by 2, in other words 3. Okay, so now I've got c equals 0, sorry, a equals 3, c equals 0. The last thing to find is b here. I'm just going to change that in case that looks like a b. That's 6. Okay, so if a, let's just put a little arrow here. There we go. If a, which is 3, plus b equals 4, well then b must equal, subtract 3 from both sides, b must equal 4 minus 3, which equals 1. So now, let's just circle these values so we can see them clearly. We've got a is 3, b is 1, and c is 0. So a little bit of algebraic work there just to sort out our a, b and c values, but once we've done that, the rest is plain sailing. Okay, so let's write down now our term to term rule. Term to term rule, which is going to look like this. So a is 3, so 3 n squared. B, well, b is 1, so plus 1n, so just n, and c is 0. So we could write plus 0, but we don't need to, because 0 of course is nothing, so we just leave that off. So our term to term rule is 3n squared plus n. But as we always say in these videos, always a good idea to check. So have we got the right answer? Let's do a quick check down here. Okay, well, we only need to check the first couple of terms, so we'll check u1 and u2, the first 2 terms, by plugging in 1 and then 2 into our term to term rule. So first of all, if n equals 1, we've got n squared is also 1. Okay, 1 squared is 1 times 3. So the first term, we'll call it u1. Our first term is going to be 1 times 3, 3, plus 1. In other words, 4. And that's good news, because our first term up here that we were given is 4. So I'll just do a little tick there. Good. So now let's check U2. Okay, let's make U2 here. So if we check U2, what have we got? 2 into the term-to-term rule. 2 squared is 4, times 3 is 12. So 12, and then 2 plus 2, 12 plus 2 gives us 14. And again, our second term is 14. Therefore we say, let's just keep this there. Therefore we say our term-to-term rule here must be correct. And then we could use it to find, higher terms. If we wanted to find the 10th term, for example, we could just plug our n equals 10 into this and find the 10th rule. So this is our key to working out, answering all sorts of other questions, but we've arrived at it fairly simply, and we have checked that we've got the right answer. Okay, brilliant. Now let's move on to the second one. What have we got? Okay. Now this time we seem to have, I don't know what it is, a bush or maybe a bacteria growth, who knows. And what's going to happen? Yeah, it's going to expand like that. So I can write down immediately what the first term, it was 1, wasn't it? The second term is 1, 2, 3, 4, 5. What's the third term? Yeah, it's going to expand like that. So we've got 9 and then 4 outliers, so 13. And the next one is going to be, how do I top that up? Let's do a little rectangle here. So we've got 5 times 3 is 15, 16, 17, and then we've got 4 and 4 is 8. So 17 add 8, it's going to give me 25. Just a quick double check. Yeah, that looks right. So 25 is my fourth term. So let's go straight ahead and find the first differences. Okay, so the difference between 1 and 5 is 4. The difference between 5 and 13, well, 13 minus 5 gives us 8. 25 minus 13 gives us 12. Okay. Now we're ready to find our 0 term. So we just work backwards to here. Well, we can see that the second difference is going to be 4, so if we subtract 4 from here, we end up with 0. And 1 subtract 0 is going to be just 1. Okay, so in other words, 1 minus 1 gives us 0, 1 minus 1 that way, and then 5 minus 4, yes, that looks correct. So strangely, our 0 term is the same as our first term. It's 1. Okay, this must be a sort of turning point, a very low point in the parabolic curve. Anyway, our 0 term is 1. Let's see now what our second difference is. Well, we've already seen that it's 4, so we'll just write those in. So that's our constant second term. Now we're ready to do a little bit of algebra. So, referring to the standard form up here, we're going to find A, B and C. Well, we already know that C equals 1, so that's the first one. A plus B is going to be 0. 2A is this term here, 4. So we know that A is going to be half of that, it's going to be 2. Okay, and to find B, all we do is take this here and substitute that 2 into that formula. We end up with 2 plus B equals 0. Therefore, subtract 2 from both sides, B must equal minus 2. So very quickly, that's got our A, B and C values. Here's our A, just pick that out there so we can see it clearly. B is minus 2 here, and C is 1. So we're ready now to write our term-to-term rule. So term-to-term rule must be, well, start with a, so a is 2, so 2n squared, plus, or in this case minus 2n, because b is minus 2. And then finally we do have a constant at the end this time, plus 1. So there's our term-to-term rule, but we do need to check. So let's write down our check. Again, just working on the first two terms will do. So u1 is going to be 1 squared is 1 times 2, that's 2. Minus 2 times 1, 2, so minus 2 plus 1. Equals, well, 2 minus 2 is 0, plus 1 is 1. So our first term should be 1. If we go up here and check, it is 1. Okay, so u2, let's do that over here. Let's see if that works out as well. So 2 squared is 4 times 2 gives us 8. Let's write that down. 2 times 2, or times minus 2, gives us minus 4. Plus our 1 gives us 8 minus 4, 4, plus 1, 5. And checking here, yes, we should get 5, so that's correct. Therefore, our term-to-term rule, 2n squared minus 2n plus 1, that must also be correct. Okay, so finally, what's our third one? Okay, so we start with 3, I don't know what they are, pots of paint, let's say. Okay, 3 pots of paint, and let's write that down straight away. So in fact, let's just label these. So that's A, B, and C. So problem C now. So pots of paint. First term is 3. Now we've got, goodness, 6 add 4 add 2 is going to give us 10. 12. 6 add 4 gives us 10, add 2 gives us 12. So our second term has to be 12. Now what have we got? Okay, well in the middle, I'm going to do it this way. So in the middle here, I've got 3 times 4, so that's 12. And on either side, I've got 6. So I've got 12, add 6, so that's going to be 24. And what have we got here? So in the middle here, I've got 4 times 5, that's 20. Okay, add 10, and another 10 gives me 40. So 40 is my final term. And, okay, presumably that would grow. So we could write it like that. Let's put that one in as well. All right, so now we're going to find our common differences. So first difference, 3 from 12 gives us 9. 24 subtract 12 gives us 12. 40 subtract 12 is 16. Okay, now if we go backwards to find our 0 term, well, we've got a first difference here of a second difference rather of 12 subtract 9 is going to give us, no, is that right? No, that can't be right. Have I made a mistake here? So 12 subtract 3 gives me 9. 12 subtract, let's just do these differences here. 24 subtract 12 gives me 12. So the difference between 12 is 3. What's going on here? 40 subtract, we've got and that would be 4. So that's not right at all. So what's happened here? Maybe what I've done is I've added it up incorrectly. Let's start again. Let's take the animation back. Ah, there we are. There's my mistake. So I should have started with 4. So let's just erase this. Okay. So I should have started with 4. Sorry about that, but there we go. The good thing about these kind of processes, in fact, is that you really can't go wrong because you spot your mistake, because it just doesn't work out. And if it doesn't work out, something went wrong. Quite easy to backtrack. So we have 4 as our first term. There we go. So 4, 12. So the difference between 12 and 4 has got to be 8. Let's write that in brown. 8 there. Okay, good. So that gives me a second difference of, oops, there we go, let's just, a second difference of 4. Okay, so 4, 4. So in other words, what I'm going to get here is 8 subtract 4, 4. That gives me my A plus B value. And 4 subtract 4 gives me my 0 term, which is C of 0. Good. And that must be, the second difference is 4 as well. Okay, now I can do my algebra. So we've got C equals 0, A plus B, well that must be this value here, so 4, 2A is 4, and therefore A equals 4 divided by 2, in other words 2. Okay, so I've got my A and C. I now need to get my B, so I substitute 2 into this equation here. So I've got 2 plus B equals 4. Therefore, subtract 2 from both sides. B equals 4 minus 2, in other words 2. So very easy arithmetic here. I'm just going to circle the values that we're interested in, the A, B and C. So my A term is here, A equals 2. My B term is here, B equals 2. And C, well, we don't need to worry about C because C equals 0. So I can now formulate my term-to-term rule. So my term-to-term rule must be, where's A? A is 2, so 2n squared plus 2n, and that's it, because C equals 0. Okay, let's just check. And for U1, I've got, okay, 1 squared is 1 times 2, that's 2. Plus 2 times 1, 2, equals 4. For U2, I've got 2 squared is 4 times 2 gives me 8. Plus 2 times 2, 4. 8 plus 4 equals 12. And here our first term is 4 and our second term is indeed 12. Let's just put this back. There we go. So everything seems to have worked out. 2n squared plus 2n must be my term-to-term rule. And that's basically how you would work on problems like this. Now you might want to just, following this video, come up with your own quadratic patterns. It's a really nice exercise to do, lots of fun. And if you come up with some quadratic functions or get a friend to do it, then you can practice this even more. But hopefully that this video has been helpful.